Welcome to part 1 of Project Management Network Analysis. What is network analysis? Network analysis is a system which plans the projects by analyzing the project activities. Network analysis helps in designing, planning, coordinating, controlling, and in decision making of a project in order to accomplish the project economically in the minimum available time with the limited available resources. In network analysis, the projects are broken down into individual tasks or activities, which are then arranged in logical or technical sequence. In network analysis, it is also decided which task will be performed simultaneously and which will be performed sequentially. A network diagram presents visually the relationship between all the activities involved in a project and the cost for different activities. Let us look at rules of network diagram. An event represents a point in time which signifies either the beginning of an activity or completion of the activity. An event is usually represented by a circle in a network. This is also called as a node or connector. An activity is an individual operation which utilizes resources and has an end and a beginning. An arrow is commonly used to represent an activity. The head of the arrow indicates the direction of progress in the project. So here, node 1 represents beginning of an activity and node 2 represents end of an activity. The activity is A, which is represented as an arrow. The events are classified into three categories. The three categories are merge event, burst event, and merge and burst event. When more than one activity comes and joins an event, such an event is known as merge event. When more than one activity leaves an event, such an event is known as burst event. An activity may be merge and burst event at the same time, as with respect to some activities it can be a merge event, and with respect to some other activities it may be a burst event. The first prerequisite in the development of network is to maintain the precedence relationships between activities. This is called a sequencing or developing precedence relationship. A network should be developed on the basis of logical or technical dependence between activities. In order to make a network, the following points should be taken into considerations. Predecessor activity. You have to ask the question, what job or jobs precedes an activities? Activities which must be completed immediately prior to the start of another activity are called predecessor activities. Concurrent activities are those activities which can be accomplished concurrently or simultaneously. The question to be asked here is what job or jobs could run at the same time. Successor activities are those activities which cannot be started until one or more of other activities are completed. The question to be asked is what job or jobs follow an activity. Dummy activity is an activity which does not consume any kind of resource but merely depicts the technological dependence. Now we look at some of the rules of sequencing. Each activity is represented by one and only one arrow in the network. No two activities can be identified by the same start and the same end events. The arrows depicting various activities are indicative of logical precedence only. The length and bearing of the arrows are of no significance. The flow of the diagram should be from left to right. Two events are numbered in such a way that the event of higher number can happen only after the event of lower number is completed. The arrows should be kept straight and not curved. Avoid mixing two directions, vertical and standing arrows. May be used if necessary. Use dummy activity freely in rough graph, but final network should have only rare dummy. The network has only one entry point called the start event and one point of emergence called as end event. Angle between the arrows should be as large as possible. Let us look at what a dummy activity is. An activity which does not consume any kind of resource but merely depicts the technological dependence is called a dummy activity. Dummy activity is represented by a dotted line in a network. If two or more activities start from the same node and end at the same node, then dummy is used. For example, look at the table. It shows three activities and predecessor relationship. Now, when you draw the network, you see activities A and B have no predecessors, therefore they are the first activities starting from the same node. Activity C's predecessor is both A and B. In that case, in such a case, we can use a dummy arrow to represent the relationship. Let us look at a problem. Draw the network for a project having four activities A, B, C, and D, which are related as below. Activities A and B can occur concurrently. Activities A is the immediate predecessor of C, and so is the relation between B and D. Completion of C and D marks the completion of the project. Let us draw the network. So, first we have the start node, and then we draw activity A arrow. Now activities A and B occur concurrently or simultaneously. Therefore, activity B also can be started from the same start event, and activities A and B are concurrent. Activity C's immediate predecessor is A. So C is represented by an arrow. Activities D is immediate predecessor is B. So here we have D, and activity C and D mark the completion of the project. That means there are no other activities, and therefore when C and D are completed, the project is completed. Therefore there is one end event where activities C and D merge. After we have drawn the network, we do the numbering of nodes using Fulkerson's rule. So the first event or first node is given one number. Starting from there, other nodes are given number 2, 3, and 4. Let us look at another problem. Here in the table, we have some activities from A to F and the predecessors. So the first thing we do is we draw rough diagram. So we have starting node. Activity A has no predecessor, so activity A is the first activity of the network. Activities B's predecessor is A, so here we have B. Activity C's predecessor is also A, so here we have C. Activity D's predecessor is B, so we draw arrow representing D. Activity E's predecessor is C, so here we have E. Activity F's predecessor is D and E. So let us put F after E. But F's predecessor is both D and E. So here we can put a dummy from E to D to represent technical relationship between F and D. That D is also a predecessor of F. But this is only a rough diagram. And after we have drawn the rough diagram, we will check the rough diagram for errors. There are three kinds of common errors in a network. First error is called as a looping error, where you draw an endless loop in a network. The second error is called as dangling error, where an activity is disconnected before the completion of all activities in a network. Third error is called as redundancy, where an unnecessary dummy is inserted in a network. So now we will draw the final diagram. In the final diagram, you have node 1, activity A, node 2, activity B, activity C, node 3, node 4, activity D, activity E, and end node 5. So you see in the final diagram, we have merged activities D and E at the same node, which is activity, which is the event 5. Therefore, the dummy has been removed from the final diagram. So if dummy can be removed, it will be removed in the final diagram. And once again, numbering of nodes is done according to the Fulkerson's rule. Let us look at another problem. So here you have rough diagram at the top and final diagram below. Once you check for errors, you see in the rough diagram we have two ends at the end. So this is not possible. A network can have only one beginning node and only one end node. So in the final diagram, we will try to remove this error. So we have activity A, activity B, activity C, activity D, activity F, G, and node 6. At node 6, activities F and G can be merged, and therefore we will have only one starting node and only one node for the network. Let us look at another numerical problem where a sequence of activities have been given with their predecessor. So let us draw a network diagram for the activities. Now activity A has no predecessor, therefore activity A can be started first. Activity B's predecessor is A, activity C's predecessor is also A, activity D's predecessor is B, activity E's predecessor is C, activities F's predecessor is E, activity G's predecessor is both D and F, and also activity E's predecessor is both B and C. So we have to use a dummy here to represent this relationship.